G'day YouTube, Warbles on a lot here, with what should be the final video about the SunGas Mark 1F. Final video about the Mark 1F because today's the day that I start work on the Mark 2. The distinguishing feature between the Mark 1E and the Mark 1F is this bracket, made out of aluminium, fabricated to precisely align the bottom of the gasification canister with the focal plane of the dish, as referenced by the black line of marking pen ink, which shows where the original microwave guide used to go, as you can see with this superimposition. This view shows you the underside of the insulation tea cosy with the canister hanging in the middle of it. It's a double layered thermal insulation tea cosy with deep wind skirts and a triple layered lid. And we have our 2 litre gasometer in a 30 litre container with a shut-off valve for the homemade burner, which I cobbled together. So far, this rig has generated approximately 50 litres of burnable synthetic gas, a combination of methane and hydrogen. And I've captured 40 litres of it, and I've burnt it to prove that it works. But I've learned about as much as I can from this rig. It's time to have a bit of a phase change, maybe a revolution in technology. So now let's review on paper what this thing is trying to do and how it tries to do it. We begin with a varnish tin, 9 centimetres across, 9 centimetres tall, 63.64 centimetres square on the base. And we put that at the focus of an offset parabolic dish, which has 3,900 square centimetres. So we're looking at a ratio of 61.28 to 1. So the base of the canister gets 61 times the otherwise normal amount of sunlight. And the central focus area is a very small area, about the size of a 10-cent piece, a couple of centimetres across perhaps. Now, of course, the hot spot wanders around on the bottom of the can depending on the precise alignment. But whatever the hottest temperature is, we're going to call that X, and that's the red spot. The yellow zone is 3/4 X. The pink zone is 2/3 of X, and the orange zone is half X. So if the hot spot at the center of the can is 600 degrees, the edge of the donut around the walls where they touch the base, 300 degrees. And I have reason to believe that the temperature at the moment on the inside of the canister is generally about half that on the outside, on the sunbeam side. So inside the canister, we have this sort of effect, where once again, if it's 600 degrees here, 300 degrees here, then you have a little tiny area of 600 degrees here, and you have 300 degrees here. X, half X, X, half X, 1/3 X, 1/4 X, up at the top of the can. Where the pipe comes out, inside the double-walled tea cosy, it's 1/6 of X. So says the electric thermal probe, which I have stuck in there. Now here's my reasoning on the point that it's half X immediately on top of the can base, regardless of whatever X might happen to be. Here's the 10th batch run of the Mark 1E, and as you can see, average temperature of 547 degrees on the hot spot on the outside of the base of the can. And 100 grams of Radiator pine made 5.95 litres of synthetic gas that I was able to burn. It also made 500 mils of unburnable water vapour. Now that's kind of significant because the pyrolytic reaction starts happening at 247 degrees Celsius. Half of 547 is 273 degrees. So it was hot enough in the bottom of the canister to have carbonised about 30% of the pine, which is what happened. The 11th batch run, 100 grams of 100-year-old stringy bark, 549 degrees average temperature. 3.75 litres of gas that we were able to burn. 39.9 grams of mass went missing from the 100-gram fuel charge. And I theorise that's because the stringy bark is denser, it took up less room in the can, so more of the stringy bark was down in the hot zone where it was able to be pyrolysed. Then we have the 12th run, 100 grams of sawdust, a couple of years old sawdust, average temperature 590.7 degrees Celsius, it's 1100 degrees Fahrenheit, on the bottom of the can. Is 295 degrees inside the can at the bottom. By contrast, I've also had a day with 100 grams of sawdust where the average temperature was only 433 degrees and all I got was 1.15 litres for the whole day. So I got a bit cranky and I went for a second day at the same tin of sawdust, and with 523 degrees average temperature I got another 2.76 litres of burnable gas, giving 3.91 litres for the 2 days. And because I'm a sucker for punishment, I did it again for a third day, and on the third day the average temperature was only 510 degrees, and on the third day it only made 500 mils of gas, and that gas was barely burnable. So what we know is if the outside maximum temperature is less than 500 degrees, pretty much no gasification occurs. Gasification occurs at 247 degrees. So yeah, okay, whatever X is, the temperature of the hot spot, and the temperature inside that can is going to be half X at its hottest. So to try and minimise the heat losses from the can, I built that tea cosy over there, and it sort of grew like topsy with additions here, there and everywhere, and it works pretty well at the moment, but it doesn't look real good, and it's not actually perfectly symmetrical, and it doesn't work as well as it could. So I've measured it, and the Mk-2 thermal insulation tea cosy should be maybe 5 or 10% more efficient because everything in it will be optimised. But stopping the heat from getting out doesn't help with getting more heat in, because inside there's going to be 100 grams of wood, and the weight of the canister without the lid is only 78.1 grams. The weight of the walls, or the mass of the walls, is 62.47 grams. That's a heat sink, that'll be radiate and heat away. And the mass of the base of the can is only 15.62 grams. So my first thought for a conduction radiator was to increase the mass of metal being impinged by the sun and poke some of that mass through onto the center of the can and let it re-radiate the heat. So conduct it inside the can and then re-radiate it into the charge. So I thought 2 washers, big ones, a 1/4 inch steel bolt, lock nuts, and that way the thread could increase the surface area of the radiator. And the mass of that setup, 32 grams, twice the mass of the original can base. My theory is if the head of the bolt is at 600 degrees, then the other end of the bolt's probably going to be, I don't know, 400, 500 degrees. I mean, steel's not a perfect conductor of heat. So therefore, I, who have a son who is an auto electrician, remembered that I'd seen some things that could be helpful in his workshop. It pays attention to notice little things, because in his workshop My Sun has some really big solid copper bolts, and copper conducts heat a lot better than steel does. So, big 3/8" diameter copper bolt with a square head on it, 2 large washers, 2 small washers. 2 small washers have to be there because the thread doesn't go all the way down the shaft, and we need them for spacing. However, I've come up with a better arrangement than the one shown in the drawing, but I did such a good job on the drawing, you're just going to have to put up with it. And the thing is, this conductive thermal radiator, 27.5 grams of copper in the bolt, with 2 large washers, 2 small washers, 2 nuts, 73 grams total weight just for the conductive radiator, going into a 78 gram can to heat up 100 gram charge of wood. So I think that's going to do a really good job, just quietly. And there you see the new arrangement where both the small washers are inside the can to, once again, increase the thermal mass of hot metal inside the can, pumping out infrared radiation, heat, energy. So ideally, with all that going for it, the Mk-2 is going to generate more gas. My feeling is that if the sun heats this bit of copper up to 600 degrees, then the other end of it is only going to be about 10% cooler. Right, so that's 540 degrees. So this 15 millimeters, 3/4 of an inch of bolt, 7.5 millimeters across, 20 millimeters up into the fuel charge, 1/3 of the height. So I have fond hopes of this idea, maybe doubling the output from 100 grams, maybe 12 litres per 100 grams instead of 6, which means that the 2-litre gasometer is just too small. So therefore, not only will the Mk-2 have the Mk-2 thermal tea cosy, not only will it have the Warbles on a lot copyrighted thermal conductive radiator, the better with which to make more gas, the Mk-2 will also have a 4-litre calibrated gasometer. And that's something I really should have done to the first one before installing it, because it's been a pain in the arse to read for all 40 litres that's gone through it. If this suite of improvements works, it has the potential to make this thing a functional unit even on a day like today, where a combination of wind blowing away the hot air from under the insulation tea cosy and haze from smoke, I think it's photochemical smog, I'm flat out getting any more than 350 degrees on the hotspot. So as it stands, performance is down, 41%, just due to atmospheric conditions. But if this works and I can get the end of that bolt glowing at 0.9x, and even on a day like today, when you're only looking at 450 degrees, you'd still have the end of the bolt at 405 degrees Celsius, which is hotter than the inside of the tin can's ever been yet, even on my best day. So now I'm going to put the camera on pause and stick it on the charger, and ideally this movie will still be available for me to finish after I've done a bit of work. Yes? What's left of 100 grams of sawdust after 3 days, and the tin was packed full. 154.5 minus 78.1, 76.4, 24.6 grams outgassed, which looks like this, working from the top to the bottom of the can. Right, I don't know how hot it is, but it looks like it's working, that's for sure. Let's just hope the aviation gasket cement can handle it. A much neater gas connection is having its silastic cured. The 2 lead weights, which used to be wired to the 2-litre gasometer, augmented by a pair of shiny new ones, chiseled from the ancestral lead ingot. The water trap in the gasometer has been upgraded, and all that checks out and fits. So when the silastic cures and the hose is connected up, it'll have the same ½ pound per square inch pressure as the previous one did. The copper bolt seems to be handling it. So once I build a new tea cozy, the Mark II will be ready to go. Ciao!